Hello, everyone. Welcome back. My name is Mr. Cobalt, and in this video, I'm going to show you how to solve a problem where you're given an equation or two reactions that give you two different products, and how to figure out what the subscripts are of the products and the percent ratio of the components. Um, so just remember, if you like my channel, please go ahead and subscribe. Don't forget to subscribe, and go ahead and like the video if you like my videos. And so with that out of the way, let's get into this. And so with regard to this problem here, so we're given element X and Y, they're gases in their natural states. We'll have to figure out if they're diatomic, monatomic, triatomic. And we're told that they react to form two different gaseous compounds. So we're looking at elements X and Y that react to form a compound. And we're given the two reactions here. So the first reaction is you're given one volume of gas X plus two volumes of gas Y, and you get two volumes of compound 1. And then you have the second reaction, you have two volumes of X, and then we're reacting with one volume of Y, and that produces two volumes of compound number 2. And so one of the things they tell us is that all volumes are measured at the same pressure and temperature. So pressure and temperature are constant, which means that we can treat volumes like moles. So 1 mole of gas X plus 2 moles of gas Y gives you 2 moles of compound 1, and so on. And then the other thing they give us is the percent of X and Y in the compound. So the ratio or the percent of X and Y is for compound 1 is this, and then for compound 2 it's this. And so finally they say, assuming the simplest possible formulas. So that's going to be important. So assuming simplest possible formulas for reactants and products, determine the relative atomic masses of X and Y, elements X and Y. Okay, so what we need to find when it says relative masses, we're looking for a ratio of masses. So relative masses of X and Y, so X over Y. What's the ratio of X, mass of X, and mass of Y in the compound? So in each of these compounds. All right, so how do we begin? So one of the first things we want to do is write out the equations. And we want to write out the equation. Since we don't know any of the subscripts, we don't know if X and Y are diatomic, or we don't know what the what the relative numbers of each of these elements in the compound are, then we're going to have to make up subscripts, and we're going to have use letters. So for the two reactions, I'm just going to write it like this. So here for the first one, I have X sub A. So that's A subscript plus 2 Y sub B. And that's going to produce our first compound number 1. And we're going to say that's 2 X sub C and Y sub D. Okay. So that's our first reaction. And again, we're treating the volumes as moles, right? So moles, so 2 volumes, 2 moles. And then for the second reaction, again, it's going to be X plus Y. So these are the same, except the ratios, the coefficients are going to be different. So here we have 2 X sub A. Since we're dealing with the exact same reactants, A and B is going to be the same. So XA plus Y sub B. Let me make that bigger. And that's going to give us compound number 2. So 2, and this time our compound is different. So we need 2 new letters for X and Y because we don't know what the subscripts are for our new compound. So here we're going to have X, what letter? So we'll have E. So X to the E and Y to the F, since those letters haven't been used yet. Okay, so there's our 2 reactions. And so one of the key things they tell us is we can assume the lowest values of our subscripts. They say assume, where was it go? Oh, here it was. Assume the simplest possible formulas. So simplest whole number ratios. So what we can do is set these equal. So we know because of the law of conservation of mass, we know that the number of X atoms on the reactant side has to be equal to the number of X atoms on the product side, and the same for the Y atoms. So we can use the law of conservation of mass to write equations for these subscripts. So since I have an A number of atoms of X, so let's say a number of X, a uh, a number of Y, or X on the reactant side, that has to equal to the number of X atoms on the product side. Since I have a coefficient 2 here and I have a subscript 2, the coefficient multiplied by the subscript gives us the total number of X atoms in this formula, in this product. So 2 times C is going to be equal to A. So that means A is equal to C. So that is an equality that we know from from the law of conservation of mass. And we could do the same for the other one as well, for the other equation. So 2A, so here I have 2 times A, so I have a coefficient 2 subscript A, so 2 times A is going to give me the total number of X atoms, so that's going to be 2A, and that's going to be equal to the number of X atoms on the product side. So I have 2 times E, 2 coefficient times E subscript is going to be the same. So 2A is equal to 2E for the second one. We can simplify this. Since we have 2's on both sides, we can simplify that by getting rid of the 2's. So that would be A is equal to E. Okay. So here we have now A is equal to 2C and A is equal to E. So therefore E is equal to 2C. So we can use that as an equality. So here we can write as A is equal to E, which must also equal to 2C. And since we can't have any fractions here, and we want this in the simplest whole number ratio, we would take the C and just call it 1. So if we just assume that E equals, or C equals 1, then we can figure out what A and E are. Since A is equal to E and both of these are equal to 2C, then 2 times 1 is 2. So that means that A is equal to 2 and E is equal, E is equal to 2. So again, because I have A equals 2C, and here I have A equals E, therefore I can put these together as A equals E, which equals 2C, and I just assume that C is 1, so that way I can get A and E, which is going to be equal to 2, because A and E are equal to 2C, which is 2 times 1. And that would give us the simplest whole number ratio between these guys here. And then I can do the same thing for Y. So if I take Y values, so if I go to Y now, so for Y is B. So 2 times B gives me the number of Y atoms on the reactant side. So I'll write that here. So 2B or not 2B? That is the question. Ha ha ha. Okay, so 2B is equal to 2 again. We have 2 there. So 2 for the coefficient multiplied by the subscript is 2D. So 2B equals 2D. And then we could do the same thing for the bottom equation. So for the bottom equation, we just have 1 y to the b. So that's going to be 1 times b is b. So b for the second equation should be equal to 2 times f for y. So that's going to be 2f. And again, for this one, we can simplify that since we have 2's on both sides. That's going to be b is equal to d. And so since b is equal to d and b is equal to 2f, that means that 2f and d must be equal to each other. So that means that b is equal to d, which is also both equal to 2f. And so once again, I can assume that f is 1. So that means that I'll say f is equal to 1. And if I assume 1 for f, then that means that both b and d are equal to 2. And so now I have figured out the subscript values for all of my atoms up here. So now I can rewrite the 2 equations with the subscripts, and these will be in the lowest whole number ratios. So, so that means it'll be x, instead of x to the a, we'll have x to the 2. So x sub 2 plus 2y, and b was 2 as well. And that's going to give us our first compound, which is 2, and then xc was 1, so we're not going to put a subscript, and then y was d, which is a 2. So that's our first equation. And then our second equation is going to be 2x, and then again 2 because it's the same subscript, plus y2. So both of our elements are diatomic according to our assumptions. And that's going to give us our second product, which is going to be 2. And it's going to be xe. Xe is 2, so 2x2, and yf, f was 1, so we're not going to put a subscript. So there's our 2 equations. So here's our 2 products. So now that we have the 2 products, we know we can see the ratio of the atoms to each other. So in product 1, you have 1x for 2 y's, and in product 2, you have 2 x's for every 1 y. So the ratio is different. And now we can use that to help us answer the question that let's remind ourselves. So assuming the simplest possible formulas for reactants and products, determine the relative atomic masses of elements X and Y. So they want the relative amounts of X and Y. X, the mass of X over the mass of Y. What's that relative amount? Well, that's where the percentages are going to help us out here. So if we do compound number one, okay, so for compound number one, they're giving us the percent, the mass percent of these two compounds in compound number one. So the mass percent of X is 30.43%, and the mass percent of Y is 69.7%. And what that means is that out of 100 grams of the compound, 69.5% is Y, and 30.43% is grams is X. So, but what we want is the relative atomic masses of X and Y, not the percentages, but we can use that to help us. Since we want X over Y, we can just assume 100 grams of this stuff and say, well, given the percentages, that would be the grams. So X number of grams would end up being 30.43 grams, and Y number of grams for compound one, if we're assuming 100 grams, would be 69.57 grams. So we could use that as a ratio. Okay, so let us do that. So the other thing to remember is notice that we need to take in consideration the ratio of X's and Y's in our formula. So for compound number one, we have 1X and 2 Y's. So we need to consider that in our formula as well. So when we set up the compound number one, the way it's going to look is that we're looking at the masses of the atoms relative to each other, right? So we need that ratio of masses of the atoms. So how many atoms do we have in compound number one? We have 1X. So we put X on top. We have 1X on top. And then we have 2 atoms of Y as well. So we're going to put 2Y on the bottom. So the mass of 1X is over the mass of 2Y atoms. And if we're assuming 100 grams of the compound, given our percentages here, then all of the X's in our compound is going to be 30.43%, or 34.43 grams. So X, that's going to be equal 43. Oops, sorry, I'm sorry. So that's 30. If I put that here, so X over 2Y is going to be equal to 30.43 grams. And then the 2 Y atoms, that would be equal to 69.57 grams. And so now we don't want the ratio of X over 2Y. We want the ratio of X over Y. So we need to get rid of this too. So now all we need to do is multiply both sides by 2. So that gets rid of that. And now we have X over Y. And so now we calculate that ratio. We calculate this ratio using our calculator. And when we do that, we get a ratio of 0.8 0.748. And so that is the ratio of X to Y in compound number 1. And then we do the exact same thing for compound number 2. So for compound number 2, same thing. So we have 2X and 1Y. So then we put 2X on top because we have 2 atoms of X in our compound, and we have 1Y atom in our compound. So 2X over Y. And now we're going to use the percentages given to us for compound number 2. And so we're going to assume 100 grams of this stuff. So out of 100 grams, we'll have 63.464 grams of X and 36.36 grams of Y. So we'll put that in our equation. So this time we're going to have, for the X, the mass of the X in our compound is going to be, let's see, hold on a second, 63.64. So 63.64 grams. And then for Y, it's going to be 36.36 grams. And so now this time we have 2X over Y, that ratio. So this ratio is equal to this ratio, but we don't want 2X over Y, we want X over Y. So this time we need to divide both sides by 2. So we're going to divide both sides by 2. And so the 2's cancel out, and now we have X over Y is equal to this. And when we calculate that, we get 0.8751 for our ratio. And that's how it's done. So I hope this was helpful. Again, if you liked this video, if you thought this was very helpful, please like the video. Okay? So hit the like button right there. If you like my channel, please subscribe to the channel and put a comment in the comment section. Let me know what you think. Let me know if you have any questions or if you want me to cover anything else in the video. Thanks for joining me, and have a great day.